Hello, welcome. So, this may be a short video, maybe a very long video, hard to say yet, but we're going to be looking at why one of my 6502 APs, it's I'm not sure what brand that is, Rockwell from the look of it, why it did not want to play ball with my code initially. That's including basic and everything else. So, let's boot up the 6502 computer and see what's happening at the moment. This has, in quotes, an authentic 6502 from Rockwell. It will run the basic program sometimes. At the moment, I'm pretty sure I'm fighting with the development board I've made, which is just a little, not a breadboard, but a perf board, everything's soldered. There's a new board coming in, and hopefully that'll solve a few issues. But basic sort of works at the moment. And this should just fail with it saying that next is without 4 in line of 30. If it works, I'll be surprised. Is it break error? Which is okay. Which is a good thing too, because I can also check to see where it failed as well. And it will do a it didn't want to do that either. Okay, so it's in a boot loop. What it's doing, I honestly don't know. Okay. Let's try that again. But this is just going outside of what I'm wanting to cover tonight. It's just an example what is not working at the moment with basic. We can list it, and then we can run it. And it's break error, and it's going to do the same thing again. Okay, so for whatever reason, it has failed, which may be related to the code I was working on earlier today. But that's not what we're here for. Let's just remove the 6502 gently. I don't like doing this. It was pretty loose, so it could be just loose in the socket, which could be an issue too. And it's not a cheap socket either. It's one of the higher quality ones, which could be causing me trouble. Worst case scenario is I just pull the socket and put a new one in there. I don't really want to do that. Alright, so this is the fake 6502. As you'll see, it will boot up, and that's all it does. It doesn't want to do anything else. It will just hang. And this is the issue I was having initially with it, was that it would not work at all. I could do something like this, print off data, print off an address range basically. But basic break error. Basic did not want to work, or does not want to work. And with break errors, where are we hiding here? I need to find out where the break address stuff is. Alright. So I've moved everything initially from in the what was it called, the 0 page, because of basic, up to a higher data area. So from 350.35F we will see where it essentially failed. F6BA is the address, and F6BA is in, that better not be the break address. Where are we hiding here? Monitor listing. We go to F6BA. F5 EF E6. There's no F6BA E6. So for whatever reason, it's tried to call F6BA and has come across code that doesn't exist, and just decided to say I've failed. But tonight, it's not the one I wanted. Cheats. There we go. So the 6802 and the 6502 are 90% pin compatible. There are a few minor differences, and one of the big differences is that there is a software interrupt, and the opcode is 3F and the no ops are 01. On the 6502, a 00 is break and 308 is a no op. I'm not sure what either of those would relate to in the other processor. I know 3F doesn't relate to anything in the 6502, so we should be good there. But to add 3F into our code, we can just add a byte there after the new line and see what happens. I haven't compiled it yet, so right. Programmer just told me placement error, but there's no power to the programmer because it's not plugged in. Alright, let's try that again. Alright, that's programmed. Place it back into the 6502. Go back to our code. Go back to the terminal. Turn on the program computer. Reset it. And that didn't do anything. Except that. So it does run basic. Well, it does try to run basic. And monitor listing at location all the way up the top. Yeah, so 3FEA, so that's added that 6502 code in there. I'm not sure what 6802 code in there. I'm not sure what a 6502 will do when it hits that piece of code. So we'll try that out now. So that was the fake 6502. Well, let's just call it the faulty 6502. Alright, so the proper 6502 is in the socket. We've got the 6802 white no up in there. It just goes straight over it. And that's where we're up to. Back to normal-ish, because we still cannot do your x equals, I don't know, 10. Yeah, let's see what it does. I haven't got any spaces in line 10. Error in line 22, so next X, and that N funny symbol means that it cannot find, it's a 4 without next, or next without 4, which is in line 10. One of the other ones it cannot do is which is F, and that is a format error. Sometimes it would do nothing at all or just fail. Pretty sure that's a format error. So try and find my OSI ROM, and it is, where's F on here? Function call error. Parameter passed to function out of range. Okay, bring that over. There we go. Nope. Yep, there we go. Get rid of putty. So these are the OSI codes. Next to Vouch 4, you got that funny symbol. Our one doesn't print those funny symbols. And function call error. Parameter passed to function out of range. Let's try the Go sub. Let's bring up putty again. And list clear. No, it's new. Okay, so 10. Go sub 70, 20, 30 is going to be end, 70, 80 is just return. Okay, so let's see if it will do that. This is just digressing because that test was inconclusive. Unless there's something to do in software as well, which we can have a look at. But let's see here. Let's run that, and it works. So Go sub works, return works. Not worried about that. Let's get rid of putty and minimize that. Just turn the computer off because I don't want to fry that chip. I had it going all night, one night, and it was nice and warm. 6502s get quite warm. And we want... Okay, so this is just the C65 wiki where they've got how to use certain functions as well. And free dummy argument. Let's not worry about that one. Let's see, we want nope. So what are we looking for? We're looking for a code 6502 code to tell the difference between a 6802. Computer science, CPU. Nope, not what I wanted. 6502 and it's all about asking questions. Okay, it's same result. Different question, same result. Macro chicken. Oh, that's tiny. Is that the only picture? Come on, where's the other picture? He's got YouTube channel too. A whole bunch of times to push buttons. Cool. Let's see, what is the schematic? 3 years ago. Okay, so the board. Oh, 6802. Yeah, I read 6502, but 6802. It's a little bit different. So 6821 would be the serial processor. What's 256? So that's 32K, 64K. Is it 8K? Can't be 8K. 64. It's be 32. Okay, getting distracted. Okay, so this is 6502 code and this is 6802 code. Yeah, 6802. Now, if we find the add with carry, ADCA, the opcodes are going to be different. So '69. So let's see, add a carry immediate 69. Add of carry immediate 89. So 6502 code, 6802 code's not going to work, so that blows that theory out of the water altogether, which is good. which means this video is a lot shorter than I realized. Still doesn't answer the question, is it a real 6502? It has to be, because or is it? Well, it can't be an earlier one, because the earlier ones were in a ceramic package and they had the ROR issue where it would not do the ROR properly. And let's see here. Okay, so page table. You've been my friend quite a few times. There you go. So now what we'll do, let's write a bit of code. Let's get rid of that. I'll bring the screen to the editor. And actually, if we move browser to the left, nope, that's not what I wanted. Browser to the left, and you guys can see the ROR code on it as well, and I'll just find the browser that I need, so I need to see it as well. Cool. Alright, so this is the byte, the illegal instruction. Software resets, and it's going to follow on the same of what I've always done for these type of programs, or this program. Question is, where do we want to put it? Now we can have it anywhere down through here, past the IRQ processor. All right, so okay, because he's going to put it in an array, 300. Into Control C, we'll put it in here, and we'll just call it okay, so we are data equals 300. Does that make sense to put it at the start of the BIOS data area? And will I be affecting anything else? Probably. Depends if I'm using those things though. So let's just put it where we're doing the math. We're not using math today, so we'll just start it off 3020. Alright, BIOS data area. Plus 30. Okay, so we don't really need the label because we can call it straight away. About LDA immediately, no, load X with a immediate value of 0. Transfer X into A. Why? Yeah, because we're loading X and A at the same time. Clear carry CLC, and then we do a could do that too. So macro, while we FF resetting, while it's end of the function, so we just reset everything. ROR A, not A0, and STA, store result in the test data, comma offset X. Increments in X, increment X, break not equal ROR test loop. Okay. Break, well, we could do a break as well, but we just do a jump to reset, and that won't reset any data. That's going to be changed to 20, and jumping to 202, which is that one there. Test loop. I've already hit. The other one is SCC, clear carry, set carry, and it's pretty much the same. Okay, so test 3. So flags into array, so flags into the array. Okay. Hit the wrong button, I'm going to save that one. I don't know what's going on. Okay, reconnection successful. Build that. Test loop 2. Okay, I've got to redefine my test loop because it's defined twice. It will get confused. Dot size is okay. Well, it's related to the first error, and that's compiled. Let's burn that to the ROM and figure out where it is loaded in the memory and run it. So on the first processor, which is the good one, which does run BASIC, I expect it to work properly. The second one, the tests are going to be inconclusive. I mean, not inconclusive. The test may or may not work. May be the same, may not be the same. We'll have to wait and see. Let's bring in the code. And I'm just going to move that to the right. Get rid of the browser, bring in putty, move it to the right. It comes out of there. And okay, that just brought up that we've got rid of the that instruction, which just goes over it. And 256 clear block. Okay, so test loop. So the first one starts off at E5. E5 C9, and we run it from there, and then at 320 dot 420 we get that. Okay, I don't have to save that anywhere, that's just on there. And then we do the same for that address there. E5D7, run it, dot 424 1F. So those are the two results that we get with that processor. Alright, let's swap the processors over and see what happens. Okay, so restart, and the first one is E5 C9, run it, and we're still working. So 320 to 41F brings up that code, and then we do the second one, which is E5D7. We run that. I could have just typed it in too. It doesn't matter. It does matter because I got to type it in a certain place for the loop, and it's got a loop. Well, that's storing it in a location, and that's looping back negative X amount of places. But I digress there. And okay, so RR, let's grab that data there. Okay, I just need the space. And we go to cheats. Okay, so that was, what was that one that I just, that was the first run second processor, first run good processor. Just try and bring it up to the same size, and just bring the space along here. That code looks pretty much identical. Okay, so that means that ROR error doesn't affect this processor. Okay, so I'm just trying to run basic again. It's saying it's a warm start, and it gets to a certain point and says, no, I don't want to know. And where was our... I forget where we put it now. Okay, so 350. And that's not valid data. That'll be from... That should be from the... from basic, but I'm pretty sure I got basic starting for 400, not 300. I'm not sure what's going on with that chip. Doesn't get as warm though. That was an interesting result. Loading warm, basic, warm start, print some stuff, quit, and then have a break error. So what is in the break error? So that's where it quit, at 06B3. Alright, am I reading that right? Higher than low. B306. I gotta remember I've said it around the correct way to read it, not the incorrect way. Now B306, that is in basic. And we can go and have a quick look in B306 dot B3 B306 dot B3 20. We'll do that. Okay. B306. I don't think that's even a location in the ROM. That's where it's jumped to. B306. The program status word is 72. So 72 is... Alright, 72, program status word, flags. Let's try and bring up, okay, the measuring ROR bug, we don't need that, and no designator, 1 megahertz, dash AP, 2 megahertz? Okay, where is my flags? Okay, so we're looking at when we got to 71, the 0 result is set, IRQ and decimals are not set, break command is set, that's always a 1, and overflow is set, which is yeah. So I did get a break from reading an instruction it doesn't know about. At location B. 306. Now to get that to actually do that, I have my finger on the processor, holding it down. Dry solder joint. Probably not, I don't know, because it works each time I put the other one in. Right. So go back to the other two chips. Because it looks like a brand new chip. Another one here, date code 8623. The first one was 8634. So that's off. Some of these won't even run in the board, which is annoying. So it's starting to feel like the socket may be a little bit on the tad on the bad side. And there should be a bolt closer to where I'm removing and inserting the chip. Alright, so this is a different 6502. Holy... That one does something completely different. Problem is, it checks out fine on the... what's it called? Chip checker. It just does the address. It sets no ops, and that's it. 8809 is this chip. I'm just swapping chips at the moment. Nothing else to do. Alright, get in the socket, you lovely piece of equipment. Maybe not. There's a couple of these that are not good. This one's 9180, 18th week 91. And the consensus is it doesn't want to know about it either. Oh. Probably because I bent a pin when I put it in there. Okay. Came out of there. Go back in. You son of a... It's like the pins in the middle are bowed out and the ones in the center are bowed in. There we go. I need to change the design so it's got a bolt right there if I'm removing and inserting chips, or just replace the socket with something lot less fancy. Alright, that's the original one, well, A6502 placed in, and back to normal for running basic. Yay. Well, as normal as it can get. Has that done that quite a bit? There should be bytes free there. And we've probably destroyed the buffer. Okay, 12, 2287. Yeah. So reset it. Okay. Alright, so what I'm going to do now is probably just tidy up some more of the code. Get rid of the ROR check that we did, as it was the results are very, very inconclusive for that processor. It probably is a 6502, but it's not doing the job. It's failed in a way that works sometimes or not. But like I said, it could also be the ROM and RAM board I've got has got an issue with it as well, which hopefully will not be in the new board that will be coming out soon, or arriving soon. And let's see the ROR test. Let's get rid of that. Okay, so it's going to be a very, very, very stupid little macro, but it's going to be a macro that tells a bit of a story. I've already got a macro for reset monitor. Got messages, I've got characters. What was the stack one down here? Oh, that's save registers. That's I'm not using that one yet. But reset monitor. Because up the top here we've got the reset. I'll probably break it if I do this. How bad did we break it? Uh, 887. So where's 887? So the reset vector goes to reset. Actually, we'll just call it start for now, because that's more of a correct term for the reset vector. That's where the processor resets, but the processor starts as well there. Thing is that when the processor does start, it doesn't do a resets. Oh yeah, I was going to say it doesn't do a warm boot. We cannot really do a warm boot because when we press the reset line, it not only resets the processor, it resets the 8251 as well, that serial port. So we can't really do that. It doesn't work for us as well. Clear input buffer, I don't think we need to do that now. Stack, we definitely need to keep that. Okay, so floppy, we could do some work on that tonight as well. Let's see what else. It's just going through the monitor. Has Intel, has Basic, has FTC boot. Which I'll need to place up in the instructions up the top and change it, but that's when we get there. So a lot of these codes, a lot of this comments are from Steve Wozniak through here. This is all his code. And then you've got my code. Save A. Okay, so there's probably an easy way to do that as well. Okay, so serial command, is it really a serial command, or are we asking status? So can we send left shift, logical shift right, and carry? So we're actually because it's in, because of where it is, if we shift right one, we clear it and become 0, or we just do a logical shift right to get it to be a clear. We could also do a compare there, but I cannot remember why. Why we do it that way. Okay, so we restore A here, and then we, because it says ASCII, we remove most significant bit here to bring it to modern ASCII. Cool. This is not my code here, but we will still load it. So we load a Y counter. And then we're testing it actually. So testing it, so if the character is 0, because these strings are all null terminated. So if character equals null, i.e. 0, we are done. Otherwise, we remove the MSB as I've stated above. Now, there's two ways we're doing this. If the most significant bit is not set, this does not set it or get rid of it or modify the data in any way. But if it is set, it removes it. This one here just removes it outright, and echo really doesn't care. Well, it does care that it's there. It doesn't really care if it's not there. It'll just process it and move on, and that's why we're restoring A here, because we're trashing it and then restoring it for the rest of the program, which sort of works. Okay, so return to subroutine. I'm not going to comment about that. Let's go. Enough comments there. This is not Wozniak stuff. This is extra. Let's see here. Again, get hex is extra as well. So macros are loaded too low down in the program. We need to bring them further up. Way up the top, way up. There we go. Okay, so macros are up the top now. So that means having them further down means that half of the program could not use macros if I want to add a macro further up in near the top of the program, such as through the start here, as I will be in the future. Essentially, from the soft reset onwards, that is the monitor. And start really is initialize, not start. So soft reset doesn't happen when you press the reset button. It's a full from the start. Basic's different as that it's knows it's got code that it can still use because that memory hasn't been cleared. Theoretically hasn't been cleared. Right, where we changed where our macros were loading in, so that means we can use them all the way through our program. Floppy drive via move 256, which is moving a block of code, block of data, delay, that was if we want to add a delay, and there may be an issue with it. Yep. Clearing block, so you can clear a block of data. I really should write how these functions are being used. Character out, which is part of a character out up there as well. That's part of echo, but difference between this character out and echo is that, where are we hiding here? This is for character out for the basic, and then get character is character in for the basic. Print line is really just the message one up the top there. Print show message. Control C doesn't work for might work now, but it doesn't work at all at the moment. Report memory size, that's going to be related to check memory. So check memory really needs to, well, report memory size reports the memory as stored somewhere in a location. That number 300 is going to change. Let's see here. Right, so that's, yeah, so this normal bit here is this bit here is going to be the interrupt handler. This is the break bit, and it just prints that error message. This is the math stuff and our functions. So see if we've broken it. I'll just assemble it and it works. So reset monitor. So reset monitor. We'll do that. So every macro starts with a M. Not PM, M. See if we broke it. Oh, it's a 69. Okay, I've made a mistake somewhere. $6.39. broke it. And 7091. Okay. And that solves that. And math or floppy disk controller. So this all depends on how often I'm typing in this bit. Okay. Okay, so those macros may not be needed, or they may be needed at this stage. We don't need that. Okay, so that expects a drive motor. This one just turns it off. And drive motors are these ones here. And okay, so these are all the functions. Just thinking about things in the future when we are going to be reading and writing from the floppy drive, and how many jumps or how many calls to other locations compared to just having a macro for that code. Depends on also how often we're calling that macro as well. It could inflate the program size, yes, and have a small impact on speed, or it could be have a small compact program size but have a big impact on speed. All depending on how many cycles the processor has to go through to do a jump, and how fast the floppy drive can get data from a sector. Let's see. The other thing is, do I need to have, well, if I want to read and write to a DOS-based disk, I need to know the structure of the disk. The program needs to know where data is after it's loaded the 512 bytes from the floppy. So if that first sector is the boot sector, it loads straight away. It has data for directory and files and a few other things as well, which will allow us to build up a, what is it called, a directory structure in memory of where things are, if we want to go that way. It all depends on how much data it requires, or you require for that data directory structure. As in, yeah, I'm going to put this in here. So in C you'd have a struct, and it's just going to be a very basic struct here. And say you'd have a character file name, and it's say 8 bytes in size. Because it's null terminated. And then you'd have an integer for the logical location of the file on the disk, or So it's unsigned int, so it's always a positive from the first sector. Well, first place anyway. And then there's usually flags as well. And just call it directory entity. And then in your program you'd have and it would be a linked list of directory entities. It would be a structure of a structure. So you'd have I'm just struggling to think of a name I could use for it, but it's directory entity, and so in memory it would look like your first structure, which is your file name and its 9 characters. Zero. And then you've got an unsigned int, so that's character. So that's 8 bits. And file name doesn't have to be file name, it could just be name. Integer, so this is just an int. In our case, it's going to be a character, and it is location. Because character is an unsigned int. And that's 1 byte. And then we got you might be saying, no, integers are bigger than that. But here in this program, in this system, we can make an integer to be 8 bits. We can make a character to be 8 bits. We can make them all 8 bits. That's just a pointer, so that's a pointer to a memory location. Alright, so and the pointer could be an integer it's a memory location, so it's going to be a high and a low. And so so this first bit is DE if we're looking here. The second bit is next. So integer is 2 bits. And then we do this. Character copy. Control V. Now this is the root. And we'll put the root at location 2000. So 2 Now hopefully you get where I'm going with this, and I'm only doing this to get my head around what I may need to do in the future for this, and that is when I am creating a structure in assembly and creating offsets for that structures in assembly. That's going to be fun and interesting. I can't count and talk at the same time. One, 2, 3, 4, 5, 6, 7, 8, 9, and we're missing some spaces. Nope, nope. Now, initially, in a linked list like this, this location here is actually but it doesn't have to be. The next location, this could be and that's the next location. That's the start of the next location in memory. It's a valid memory location, but it's 0, so it's null. And anything below, so 3, 4, 500 is not a valid memory location for this type of structure. For completion, we can add the rest of it, but that's essentially how that would work and look in memory. I'm not going to go through how that would yet program that in assembly yet. C's easy. Assembly is a little bit more involved. Though you do not have to worry about much boilerplate overheads and setting up functions and stuff. Whereas C, it does that for you. Okay, is that process is still working? And we go list. Yeah, it's still working. Toasty. Ooh, it's toasty. It's about 44 degrees. 45. My limit's about 44 degrees. I'm touching stuff, so Don't know how warm it is. Alright. So let's go through the the floppy drive structure, and add that to. It's 20 past 11. Let's add that to the mix. If you are interested in the floppy structure, I'd suggest you have a read on it online. I'm not really covering it today. I think it's FAT 16 or FAT 12. Let's see, April, August. Okay, so FAT 12. Alright, I'm just looking at stuff. Okay, so where do we find more about FAT 16, FAT 12? This is not going to be easy. I've got a whole lot of data. I'm going to bring up the browser. And putty, and it's wrong page, and it is design of the FAT file system. Okay, so boot sector has the jump instruction, OEM name, BIOS parameter block, in the boot code, then the drive, physical drive number. Physical drive number. Right. Boot signature sector. That's the end of the 512 bytes. One FE. Alright, so first 25 bytes of the BIOS parameter block is used by FAT versions since DOS 2. Bytes per logical sector. Logical sectors per cluster. Counter reserved, FAT number of FATs. Tautological sectors, media descriptor. Okay, so that would be a good way to see if we're actually reading the disk correctly. 3.5 inch, 80 tracks, 18 to 36. And single-sided, double-sided. Alright, different sizes as well. F9. Okay, maybe not. What was that? That was... Okay, there's the BIOS parameter block. Let's go back all the way up here. Okay, we got the boot sector. Okay. File system information sector, we're not worried about that. FAT1. Okay, how the hell does that work? This turn tree span 3 bytes. And Little Indian. Let's not worry about that, it's getting distracted. Okay, so that and that, cluster 1, cluster 2, cluster 3, 7 clusters, 1, 2, 3, 4, 5, 6, 7. But there's that many because it's 3. So 1, that's there. So 2, where's 2? 4. So I've got 3, 4, 5 and 6, and 7 and 8. But I do not see 2. Because that's part of that's part of that. That's part of that. So that's part of that. That's part of that. Nope, it's 3 bytes. So I'm saying there. That's part of that. That's part of that. That's the next part. Okay, I'm going to have to read through that and try and understand a little bit more. And it's late at night, so I'm just going to leave it there. And see you guys some other time.